right? We have two main equations. We have standard form and vertex form. The A value in standard and the A value in vertex are the same. The A value in standard and the A value in vertex are the same. All graphs are going to be symmetric through an equation. That equation will always be x equals. If you are in standard form, then it is negative b divided by 2a. And if you are in vertex form, then it will be x equals h. We have different Yes. So like if the formula, because the formula itself is x minus h, so the h value in the formula is the opposite in here. So like if this is x minus h in the formula, this h is positive. If it's x plus h in the formula, then it's negative, because what's happening is you have minus a minus, and that's why you're seeing it as a positive.
So they're opposite signs.
Yes, like the h value in the axis of symmetry is always the opposite sign of what it is in vertex form. If the a value is positive, then your graph is going to open up. That also means that your graph is going to have its vertex as a min. So its vertex is a min, and it is concave up. If your a value is negative, then we say that the graph is reflected. My vertex will be a max, and my graph will be concave down. The h value is the horizontal translations. That shifts my graph left or right. And then this is kind of what we were just discussing with the h value being positive or negative inside. So the graph will go left when your h value appears to be positive. It will go right when your h value appears to be negative, but that's because of the nature of the equation, not the actual h value itself. The k value is your vertical translations, which means you're going to shift up if it's a positive k, or down if it's a negative k. The h value will affect the x's. The k value does not want to focus. The k value will affect the y's. The k value also affects the range. So the k value is going to affect your range. The vertex in standard form comes from negative b divided by 2a, and then plugging that in to solve for k. So when we plug something into a function, we put it in function notation as f of whatever you're plugging in. And then it's important to note in vertex form, the h is that negative b divided by 2a, and the k is plugging that value in. So we can describe the transformations of a quadratic function based on its vertex. If the vertex is 3, 4, Then that 3 moved my graph right 3 units. That 4 moved my graph down 4 units. Since I don't know anything about A, I don't know any of the other transformations. We can convert an equation from one form to another. We can also write an equation. Which one do you need, Ella? Sorry, it should say up. Don't listen to me right now. No, I don't know what's wrong. That was just me being dumb. Yesterday, those kids killed me. Today, that was just stupid. All right. The vertex is 1, 4, and the H value is going to tell me my movement to the right. The K value is going to tell me your movement down. The point is another point on my graph. So what happens is, in order to get this into vertex form, I need to find my A. So I know H, I know K, and I can use X and Y. So we're going to say that Y is 3 equal to, I'm going to look for A. I'm going to plug in 1 for X. I'm going to subtract, because that's my formula, my H, which is 1/4. I'm going to take that answer and square it, and then my K is -3/2. And my pen down. So then order of operations tells you that you have to work inside and square before you do anything else. So you're going to take your 1 minus 1/4 and get 3/4. You're going to square that to get 9/16. Multiplication is commutative, so I have a tendency to, after I get my answer, to take it and rewrite it in like normal form, where my number is in front of my variable. And then you have -3/2. So I'm going to add 3/2 to both sides. And so 3 plus 3/2 is going to give you 4.5 or 9/2. And then you're going to multiply by your reciprocal. And what's super nice is that when you multiply by the reciprocal, the 9's cancel. And you get 16 divided by 2, which is 8. Solving for A, though, isn't what the problem asked for. It asked you for the equation in vertex form. So you're going to take your A, take your H, take your K, and plug it in to vertex form. So on the back, the first graph is in vertex form. That's how we started our unit. Your vertex is the opposite of what's inside. So -1, 1. Your AOS is always x equals h. So in this case, x equals -1. If the A value is negative, my graph is opened down like a frown, which means I have a max. The max is always at k. So in this case, it is at 1. And then domain is always all reals. My range has to do with my k value as well as my a value. So if the a reflects my graph, then my y values are now going to be less than or equal to my k value, which is 1. And then we want to take all of those transformations and put them into words. So a negative is reflected. An a value greater than 1 is stretched. A -1 inside moves my graph left 1. And a +1 outside moves my graph up 1. You can cross off the roots. That's what we're going to focus on next week. So we don't have to worry about those just yet. Plot your points, and if you like the table, this is when I would construct my table. So it's x minus h, and then ya plus k. So 0 minus 1 is -1. 1 minus 1 is 0. 2 minus 1 is 1. And 3 minus 1 is 2. And then your y's go 0, 1, 4, 9. 0 times anything is 0. So 0 plus k is 1. And then 1 times -2 is -2. And -2 plus 1 is going to give you -1. And then, so 0, 1, 4 times -2 is -8. -8 plus 1 gives you -7. And then your last one's 9. 9 times -2 is -18. Plus 1 is -17. So you have -1, 1, 0, -1. If you have 0, -1, you also have -2, -1, because whatever it does to the right, it does to the left. And then you have 1, 7, and -3, 7. Vertex form is the easier of the two to graph. Standard form requires you to find your vertex. So then we have to find our h value. So in this case, b is -4. So it's 4 divided by 2 times 2. So you get 4 over 4, or 1. To find my k, we're going to take that 1 and plug it back in. So 2 times 1 squared minus 4 times 1 minus 6. So then you have 2 minus 10, which is -8. So my vertex is at 1, -8. It's going to be symmetric through x equals 1. My a value is positive, so I have a min. My min is at k, which is at -8. Domain is all reals. My graph is open up, so my y values are greater than or equal to. And then they're greater than or equal to k, so they're going to be bigger than -8. An a value of 2 will stretch my graph, and then it is shifted right 1 and down 8. My table so we're going to add 1, multiply by 2 on the y's, and subtract 8. And then plot your points. You will always kind of check yourself. So I have the 2 and the -6, right? So this value right here is also our y-intercept, which means I should have the point 0, -6. So I can see when I do my symmetric graphing that it is also, in fact, my y-intercept at 0, -6. So you can see your graph is stretched in both those examples. The stretching are the same. They're both by 2, so they're more narrow than the parent function.